All right, let's talk machine learning versus deep learning. They both learn from data, right? So what's the big deal? What's the actual difference? Well, it turns out there's this kind of secret ingredient that changes everything. Let's get into it. I mean, look, at their core, both of these AI methods are trying to do the same thing, learn from a bunch of data. So if they're both learning, why do we bother with two different names? What really sets them apart?
And here's the kicker. The real difference isn't what they learn, but how they learn to see the world. It all comes down to how they make sense of the information we feed them. How they build their own picture of reality, right from scratch.
And that brings us right to that secret ingredient I mentioned. It's this concept called representation learning. Seriously, if you can wrap your head around this one idea, you'll totally get the difference between ML and DL. It's the key to the whole thing. Okay, so what is it exactly? To put it simply, representation learning is just the process of taking all this messy, raw data and automatically figuring out the best way to organize it. The whole point is to whip it into a shape that makes it way easier to spot patterns or make predictions. Think about it like this. On the one hand, you've got raw data. For an image, that's just a giant chaotic sea of pixels, a jumble of numbers that don't mean anything by themselves. But on the other hand, you have a good representation. The machine has actually learned to group those pixels into useful concepts, what we call features. Things like has whiskers, is furry, has pointy ears. Suddenly, it's not just pixels, it's the building blocks for identifying a cat. So let's first look at how traditional machine learning, or ML, handles this problem. Its whole approach is basically about human guidance. It's a process that has a name, feature engineering. Yeah, in the classic ML world, the machine is kind of helpless at the start. It doesn't just figure out what's important on its own. Nope. Instead, a human expert has to step in, someone who really knows their stuff, who can look at the problem and say, okay, the important things, the features, are the number of legs, or the texture of the fur, or the shape of the nose. They hand-pick the clues. And it's a very clear three-step process, right? First, the human expert dives in and analyzes the problem. Second, they manually, and that's the key word, they manually design and pull out all those important features. And only then, after all that human work, does the ML model get to train on this perfectly prepared, handcrafted data. It's a really solid approach for sure, but you can already see how it's totally dependent on that human expert. Okay, now let's flip the script and look at deep learning. It takes a completely different path. It's a self-taught method. The magic here is what we call automatic feature learning. So, unlike classic ML, a deep learning model doesn't need a human holding its hand, telling it what to look for. Instead, it's using these deep, multi-layered neural networks to figure out the important stuff all by itself, straight from the raw data. It builds its own understanding, layer by layer, from the ground up.
So how does that actually work? Well, picture it this way. At the very first lowest layer, the model starts super simple. It's just learning to spot the most basic things, like simple edges, corners, maybe a splash of color. It's just looking at the raw pixels and finding the most primitive patterns.
Then, the next layer up takes all those simple edges and colors and starts putting them together. It's like building with Legos. It's not just seeing lines anymore, it's starting to see more complex things, like shapes. Eyes, noses, maybe a wheel, and different kinds of textures. And finally, the top layers take those combined shapes and textures and assemble the final puzzle. This is the aha moment. This is where the model finally recognizes the whole object that we would understand, like that's a car or that's a dog's face. And the amazing part, it figured all of this out from pixels to concepts completely on its own, one abstract layer at a time. So there you have it. Two totally different ways of doing things. One is guided by a human expert, the other one basically teaches itself. And as you can probably guess, this creates a really big trade-off, a trade-off between raw power and simple clarity.
And this really breaks it all down. With classic machine learning, since a human is crafting the features, it can get by with smaller data sets, and it's way easier to understand. You can actually follow its decision-making process. But deep learning, well, it learns those features automatically. That's its superpower. But to do that, it needs a ton of data and some serious computing power, like GPUs. The payoff is that it's amazing at generalizing to new problems. But the biggest downside, the thing everyone talks about, is that it becomes a black box.
And that right there, that is the absolute heart of the trade-off. With some ML models, like a decision tree, you can literally draw out the path it took to make a choice. It's logical, it's clear. But with deep learning, That path is buried deep inside a tangled web of millions of tiny connections. It's opaque. It's almost impossible for a person to look inside and really understand why it made the decision it did.
Yeah, millions. That's the kind of scale we're dealing with. Millions upon millions of little knobs or parameters, all getting tweaked and adjusted inside the model. This is exactly what gives deep learning its incredible, almost magical power. But it's also the very thing that makes it so hard to explain. It is, quite literally, a black box.
So, where does that leave us? Is one just better than the other? Should we pick a side? Well, the future of AI really isn't about picking a winner here. The real goal is to create something new, a kind of hybrid mind that can combine the best of both worlds.
You know, the goal for researchers in this field isn't about machine learning winning or deep learning winning. It's about finding a way to merge these two powerful approaches. The dream is to build intelligent systems that aren't just powerful, but also transparent and something we can actually rely on.
And this is where all the really exciting, cutting-edge research is headed. People are working hard to combine the interpretability, the clarity of classic ML with the sheer representational power of deep learning. They're exploring these new hybrid systems, trying to get the best of both worlds, deep learning's knack for spotting patterns, and the kind of step-by-step logical reasoning that we humans are good at. The endgame? A smarter, more robust, and more understandable AI.
Which brings us back to the ultimate question, doesn't it? This secret ingredient, representation learning, has given us AI tools that are unbelievably powerful. But the huge challenge, the defining mission for the next generation of AI, is bridging that gap between power and trust. Can we build an AI that's not just powerful, but also trustworthy, an AI we can truly rely on? That's the big question that's going to shape our future.